Audio recording for this meeting has begun.
Okay, a little different today. I'm hosting the meeting from the middle of a snowstorm. So there's a little picture of outside my house earlier today. I think we're up to about 5 feet now. I'm right in the middle of the snow belt. So, but it's great with technology that we're able to do this. Hopefully you're all staying warm and hopefully have a little sunshine wherever you are. A couple of things. My name is Molly Marin. I'm the webinar coordinator for the New York State RtI Technical Assistance Center. The PowerPoint for today's presentation is posted on our webpage. If you wanted to follow along with that, you're welcome to do so. At the end of today's presentation, I will post a link to an evaluation. If you could please take a few minutes to complete that, we really appreciate the feedback. Also, during today's presentation, if you can use the chat box for any questions or comments that you may have, Dr. Gersten will take a break at midpoint to respond to some questions, and there'll also be an opportunity at the end for questions. Today is the first in our Understanding RtI in Mathematics series. We hope you can join us for the other webinars in this series, as well as our Strand 7 series, Database Decision-Making in an RtI Process, and that starts December 1st. More information and registration information on all our upcoming webinars will be available on our webpage. Please check that out. And we are very, very pleased to have Dr. Russell Gersten with us today. Dr. Gersten is a professor with the College of Education at the University of Oregon and Director of Instructional Research Group in Southern California. He served on the National Math Panel, co-chairing the Committee on Instructional Practice. He also chaired the panel that created a practice guide for RtI mathematics for the U.S. Department of Education. In his 20s, he reviewed R&B for Rolling Stone and the Boston Phoenix and interviewed many of the stars of that era, such as Al Green and Gladys Knight. Welcome, Dr. Gersten.
Good afternoon, and I think what I'll do is just take it from the top, starting with the title, which was not, the actual titles and the structure was set by the TA Center, not by me, but it kind of pushed me into raising issues and thinking about things that I think are going to be very, very useful for you, and that's probably especially true for this afternoon session. I liked very much the title of this series of talks, which is not a how to do it. I know that there have been some other webinars in this series that have talked a lot about how to schedule and various other critical things for RtI running well. But in math, I think it is initially very important to understand what the issues are and what the evidence is. We do not have the same reading research base that beginning reading has at all, and we do not have 10 to 15 years of people trying out models and evaluating them. We really have essentially a series of ideas, pilot projects, some increasing research studies. So it really takes some understanding to put together a good RtI system. My sense is that the state requires RtI in reading K4, but is moot in terms of math or upper grade intervention. So I assume all of you are thinking of RtI in math, perhaps beginning it, so questions are welcome, but our goal is really as much to understand what the issues and the evidence is. I'm going to quickly give an overview of the 4 webinars in the series, and they'll all be the same time on Tuesday afternoons. Here we're going to talk about RtI in the context of the Common Core. I'm aware that New York is probably one of the first, or certainly one of the few states to begin Common Core implementation and to experience some of the problems and confusions early on. Many of them are now being experienced in the other states this school year. But it is very important to think about RtI, and given some of the profound changes in math instruction that the Common Core stands for and what impact it's going to have for our group of struggling kids. So what I decided to do is flip things around a little bit from the original thing and focus almost exclusively on effective Tier 1 or core math instruction, because for several reasons. This is what RtI needs to support. This is what RtI needs to prevent failure in. So if you don't understand what the target is, and the Common Core standards are a bit of a moving target in this country at the current point in time, it really, a lot of the interventions and all may go a little bit sideways or back and forth, etc. And one thing the Common Core is not very good at is explaining the underlying thinking. I have this advantage of both having served on the National Math Panel and gotten to a series of, if sometimes quite fractious, but always interesting, insightful conversations with some of the people who were very instrumental in various phases of the Common Core, and developed a way of understanding some of the things people are trying to do and some of the non-issues as when red herrings, as well as what really is going on. I also have the advantage of being an applied mathematician and having studied math pretty seriously, which gives some insights into some of the things that the Common Core standards themselves, or most state standards, be they current or old, are not very good at doing. Next week I'm going to really do a bit of a framework on what RtI is, and we'll start off with that framework. I'm going to share some very, very recent research. I'll try to do that each session a bit. I'll do some at the tail end today. And then we're going to, we'll talk then about the importance of kindergarten and first grade in particular, and what some of this quite new research has illuminated about it. And then similarly, what I see, and this is setting the stage for the two key target areas if you're beginning interventions. One would be, as with reading, young kids, K1, pre-K if it is possible and feasible. And the other is as students begin to learn fractions, which begins intensively in fourth grade. It's certainly introduced in third seriously. And those, so I want to share some of that research, and then I will share some information and some ideas about screening and looking for screening measures. That will probably be the most familiar territory for those of you who have background with RtI and reading, because the basic procedures are about the same. The next two sessions, the third one, which is December 2nd, will kind of get at some of the heart of the issue, is what to teach in intervention and how to teach it and what is current thinking about best practices. And there's a lot of convergence and divergence there. So we'll go through some of the controversies and most importantly, some of the commonalities. And I'd like to at least give you a sense, because I know the question when I've done these face-to-face, and it may come up today, is people go, well, what program should we buy for our Tier 2 or Tier 3 intervention? And at least I can give you some criteria for what to look for and what if it's not there, you need to add in. And then the last one I'm going to do jointly with Professor Sarah Powell from University of Texas, because that way we can cover progress monitoring, which is not my forte for reasons I think you'll see, and is her forte, but also talk especially about its importance in Tier 3 or intensive interventions. And she is one of the leads in the math area for the National Center of Intensive Intervention, which she'll introduce you to some of the materials. So that one, we're going to have that dual focus. Let's start. I think it's always good to do a few of these to break things up, and I have a few problems and a few polling questions, but if you could just fill this out, should not take long. Do another 10 seconds or so. Okay. Okay. I think this is this of course gives me a sense of the audience, but also gives you a sense of who your colleagues are throughout the state. And that number for the top, loving mathematics, is a high, and it's a wonderful number. And one reason it's good to know that is, especially for those of you working in elementary school, but it's equally true in the secondary level, it's just things are departmentalized. It is such a norm for people to say, be they teachers or people in whatever line of work, that just, I hate math, I'm not good at math, I don't like math, and the idea that, you know, to be able to be around people who love math is a wonderful experience, because many of us rarely feel that. I guess it's less true if you're in a middle or high school math department, and it's equally true in special ed. Most special ed folks often focus in reading, you know, focus on reading. I'm just looking at a couple of the comments. Is this mostly elementary school? We'll get to that. We're going to poll people in a second, and I think someone has a question for Molly that she can deal with. But it's just good to know this, that we're mainly with a group that can either, we're with a group of people who like math and who like thinking about the issues that what really is math, and rather than how can I get it over with, or how can I get my kids to pass the test, as opposed to really a love of math and really brooding and thinking about how to do it better. And that looks like it covers close to 90% of our group. Now we're going to move on, and I put this in with some hesitation. There was a little slot in the outline the state gave to talk about the framework for RtI. I'm sure many of you have seen this so many times you might want to scream. I'll try, especially for Tier 1, to make it a little different than what you may hear. One reason I don't use those percentages that many of you see where it might say 70% or 80%, Tier 1 is all they need. Those numbers, they don't come from real data about school children in reading or mathematics. They come from other areas of public health and et cetera. And for that reason, I think it's better for us to just know what the terms are. Tier 1, people always say it's important to start with Tier 1. You have to have Tier 1. A strong Tier 1 program needs to be in place. It's somewhat true, but it also makes a very complicated situation seem easy and simple-minded. Everyone agrees universal screening is part of Tier 1. Beyond that, 1 second, I am losing my connection. So what I'm going to do is get my tech person. It'll take me 12 seconds. John, the connection's gone. I have a paper copy, so I'm going to just keep going. But Tier 1, one key thing about it is people differ in what they say. They say it's evidence-based instruction. They say it's high-quality math instruction. To some, it's differentiated instruction, where there's a time during Tier 1 where kids get to work in small groups with either the teacher or somebody at an appropriate difficulty level. But the key thing is that, yeah, okay, with that, thanks. But the key thing is that there are many, many things to say about Tier 1. And as you'll see in math, there's far from a consensus to it. So is it scientifically based math instruction, which would give you a very, very narrow amount of things to do? So Tier 1 in math, if people just give you the bromide, get Tier 1 in place first before we start. Tier 1 is never ending. It's how do we teach math better? How do we do it in a way that will be achieving better than the current international performances? It's changing rapidly. So Tier 1, all of the things on this slide make some sense, having professional development, having some type of meaningful differentiation, especially not giving students work that's much too hard or much too easy for them, but it is really far from clear what it is. Tier 2 is a little clearer, and I think most of you are aware of it. It's meant for at-risk learners. Some estimate a third or a quarter of the kids. The general thinking is that you probably will need to figure out whether it's aligned, and we're going to keep talking about that, how much it should be aligned to the core curriculum versus what I have as point 3 there, backtrack, elaborate, reinforce classroom curriculum. No clear picture, nor one thing to think about is, though progress monitoring is often recommended, we're going to look at our next session at what the data really tells us about progress monitoring for Tier 2. So what I want to do now is in Tier 1 at least, and looking at some of the comments, I know there's some folks who are familiar with RtI only in the English language arts, some who are new to RtI from high school. So your backgrounds are going to vary. There's so many sources, and I'm sure the TA Center, their website would share basic things to orient you to what RtI is. But I want to spend most of today, the remaining, 45 minutes, and then there'll be Q&A time, to talk about Tier 1 instruction in the era of the Common Core. And there are so many misunderstandings about this. And I intentionally call it Beyond the Math Wars. The Math Wars, for those of you who don't know much about them, they've been going on for a long, long time, probably at least since the 1960s, when there were the beginning attempts to reform American math. But essentially, there are, at the extremes, there is a group very committed to teaching for understanding and feeling that much less time should go into teaching procedures, or in some extreme cases, almost no time. And by procedures, I mean the algorithms of multiplying, dividing, reducing fractions, that sort of thing. And people attack each other, and it's very ugly and unpleasant, but it has helped elucidate some issues, and it's also going to help you as you go through choices of intervention programs or textbooks to get a different sense of which is which, and how you might make sense of it for yourself or your school. RtI in math is relatively new. There have been some intervention studies, particularly in the last 5, 6, 7 years. There are many divergent views. Probably if you get 6 experts in RtI math together and you go beyond the surface, they will disagree with each other. Some of the areas they disagree on may simply be irrelevant to student success. What I want to do is explain some of the perspectives that you're going to run into, especially as you try to build up an RtI program, be it in high school or primary grades or middle school or double-dose algebra, or sometimes middle schools have double-dose math for kids to kind of get them ready for algebra. Just seems understanding the perspectives is important, and it also seems understanding the evidence base where there is an evidence base. And many people claim there is one, but I'm talking about pretty rigorous evidence. So I want to go through that. Especially when we have evidence, I'm going to talk about what it means, even if it isn't always as pretty and clear-cut as folks had hoped findings would be, because that is one thing about science. As education adopts scientific methods, things aren't as simple as they seemed. And I'm going to share with you, at least not a vision, but give you a sense of a type of explicit math instruction that seems like it would be extremely useful in Tier 1, and that will be new to some of you and possibly not at all to others. Our goals tie into the context. I want to try to give you a framework for understanding what should be in Tier 1 instruction and what should be in the curriculum and what should be in practice. And those of you who are psychologists or interventionists or RtI coordinators, it's good to have a vision of what are sensible things and combination of things. This ties into the context statement. I'm going to introduce the research, talk about where there's tensions and confusions, and towards the end give you some very recent research that's just come out, in one case in the last few weeks. And the goal is to understand what the goal of an RtI multi-tier system of support is, which is making sure the content, the core content, is grasped by virtually all students at a given grade level. This is our second poll, and you see it here, and again, it shouldn't take you very long. This will give me and all of us a sense of who's on right now. And Molly, you can give me a sense when we have most all of the 76 or so of us. Okay. Looks like we're pretty much there. So we see a fifth, the largest number are RtI specialists or coordinators, which makes a lot of sense. Some math teachers, which is great, because one thing as RtI and math spreads, it is often math teachers who get involved, especially if there's this double dose idea. Special ed, we have a sizable proportion. School psych, sizable. A lot of interventionists, which is great because RtI depends on interventionists, and in many cases, and there are some exceptions, skilled interventionists are phenomenal, and there are people who are volunteers or are paraprofessionals who've been trained to do that, but you can't count on everybody being a good math interventionist. So this gives us all a sense of who we are. And now we're going to start with, to me, the two main themes in the Common Core. And I know you probably had more orientations to the Common Core, and I don't want to belabor them. Let you put in comments if it is belaboring them, but this is my own take after reading it, hearing attacks, reading panaceas, reading people who've tried to look at learning progressions in depth. What we want students to be able to do is to understand the reasons behind the procedures, because that is what advanced. And they should be able to do it at different times and obviously in different ways, from a 6-year-old in first grade to a teen in high school, but orally, in writing, and through diagrams or visual representations, which is the more formal term. And the reason for this is it sets the stage as early as first grade or even kindergarten for being able to prove something. Suddenly formal proofs are introduced in geometry, at times in algebra, and certainly they become one of the key things in math from then on. But the idea that you can begin to prove and reason and support evidence and use logic to understand and demonstrate understanding is probably the key thing that's hit in the Common Core, and it's explicit, as we'll see. And that needs, to me, to be in all tiers of RtI, demonstration of understanding. It is not the only thing that needs to be. The other thing the Common Core does, and I don't know that they say it explicitly themselves, but it's clearly there, is that there is a linkage between algebra and elementary arithmetic. Algebra, one way to think of algebra, it's not the only way, but one way to think of algebra, especially first-year algebra, is it's a general case of arithmetic. And so introducing the ideas of algebra and these mathematical ideas as you're teaching addition, subtraction, etc., whole numbers and then fractions and decimals, is a way to develop this insight. And one advantage I have, having a background in both literature and music, but also in mathematics, is mathematicians talk a lot about insights, about how you really understand an idea, a concept, why a proof is important, what a term means. You really understand it when you immerse yourself in solving problems. You get insights into it, just like in ELA with close readings, people get insights, deeper insights into what the author of the poem or the short story or the piece on a famous historical figure tries to do. Good deal of arithmetic's an extension, and it's been in textbooks for quite a while, but it sort of sometimes sits there. Extensions of the properties, the commutative, associative, and distributive properties. And you want kids to not only memorize those terms and be able to show it to you, but really have a deep feeling for why it is, why it permeates all this. And that can only be done by solving problems and explanations. There's a heavy emphasis on demonstrating understanding for that reason, and there's a heavy evidence on visual models, graphic models, the use of a number line, the use of a small set of visual representations, because that way kids have a tool to show their understanding, to begin to prove what they know and are thinking. The other thing that's the obsession in the Common Core is the number line, and this is it was just a public access website, but the number line usually gets very kind of formal, so it was kind of nice to see the happy frog there. But this title, Life on the Number Line, comes from a colleague of mine, Dick Askey, who's a professor emeritus at Wisconsin, who sends email. A lot of times mathematicians like to send emails like midnight, 3 in the morning or whatever. So one of his midnight missives said, Russell, mathematicians spend most of their lives on the number line. Now it seemed a little, didn't seem like the most exciting life in the world. Driving into work, I was hearing about the 93-year-old who spent 40 years of his life basically just surfing and traveling around the country and the continent. But it is true that it's living in an abstract world, and the number line is a great tool for doing that. And that is one of the reasons it's stressed so heavily in the standards. Other things that come up, which I think are going to lead us to these musings and sharing some of the research and examples from, on Tier 1, is teaching fractions more than one and less than one concurrently. And the reason for doing that is if in a certain grade, second grade or third grade, you teach kids a fraction is a part of a whole, and then the next year you're giving them fractions like 9/5 and 20/3, and saying, well, 20/3 is the same as 6 2/3. Kids feel betrayed. They say, wait a minute. Last year my teacher told me fractions part of a whole, now suddenly, and they get mixed up, and the mix-ups is shown in poor performance. So things like this are trying to prevent misconceptions. Another thing is, and this is less the Common Core and more a lot of the best thinking in math, and it comes a lot from high-performing Asian countries like Korea, Japan, Shanghai, Taiwan, and those countries, is integrating word problems with computations and things involving mathematical operations, and doing that from the onset. I became convinced of this 11 years ago. I opened up a Singapore math textbook, first grade, first day. And of course, they're starting to do a little bit of counting and very simple addition, adding 1 and 2, subtracting 1 and 2, stuff that kids kind of know. And so there are a couple of computation problems, and then there are a couple of word problems, but the word problems at the beginning of first grade often are mainly pictures because kids can't read that much in most cases. But the thing I realized is, gee, what happens is the word problems give meaning to the computations, and the computations are showing kids that math is efficient because it abstracts out. So when you're doing 8 plus 1, it doesn't matter if it's 8 ducks or 8 peanuts or 8 whatever. And it's so much more interesting. So the way we typically learn math, we had maybe computational work. For me, the first day with some modeling and some of the reasons why. Then you do more and more practice on, let's say, multi-digit multiplication. And then you'd have a couple of days with word problems. And what happened with the assignments, the computation assignments, would start to get boring by the time you got to problem 11. And when you had the word problems and you had 16 word problems, they would start to get boring. So this is more interesting, and it also hopefully is a way, if it's taught well, that you can understand the meaning of the computations better. The other thing we're going to see that in the video is the ideas and the procedures, which often in elementary grades is computation, are linked together. And they're not linked together every single day all the time, but there's a clear linkage there. It's not, I explained why, which was often the way I learned, so it was explained why once, and then for the next 2 weeks you're dealing with procedures and word problems. And the major stress in the number line is no surprise to anyone in New York State familiar with the math standards. So the thing is, we have these principles and ideas, but it doesn't yet tell us exactly how to teach. So that's what I'm going to try to probe some guidelines. Before doing that, there'll be a bit on fractions, and we'll keep having examples on fractions. And this was just a nice thing I thought would throw in why it's so important to teach fractions well, why it's so stressed in the Common Core. And these are some of the reasons we think fractions are so hard for kids. That numbers of exactly the same magnitude, like 3/4 and 9/12, look quite different. Sometimes, or often, when numbers get bigger, the fraction gets smaller, which is very anxiety-provoking and confusing to students when they start really digging into this 3rd, 4th, and 5th grade. And to make it worse, it's not always the case. So in this case, 7 is a denominator, it's bigger, but 2/4 is certainly less than 6/7. So it is a so much more complicated world than whole numbers. And without really understanding these rules, it's so easy to get mixed up. And then the other one, which you can't so much formally teach, but you can build insights into, is that there are an infinite amount of numbers between two fractions. So between 1 and 1 1/4, there's an infinite number of fractions between them. Between the numbers 1 and 3, there is one whole number between them. There's an infinite number of fractions. So the emphasis on fractions and the amount of time that goes into fractions is probably the last major key idea or insight in the Common Core, at least at the K-8 end of it. It's basically stressing fractions as a point on a number line, which is much harder to teach. For those of you who have access, and that's why I've given you, and I know Molly will speak to this at least at the end or maybe before we do our questions about how to get copies of the PowerPoints and all that kind of stuff. I see there's some queries about that. But you can just then use that to locate this article. It just came out very recently, I think a few days ago. It's, to me, a very nice explanation of some of the major changes in the Common Core. They spent a lot of time, the reporter, talking to Bill McCallum, who's a mathematician in Arizona, and it just explains things pretty nicely, and it would seem pretty easy to follow, but it's definitely a key issue. Now, one of the problems in Tier 1 instruction is we're really being asked to teach math differently than how we learned it. A second problem, and those of you who are math coaches, RtI coordinators, or just providing interventions to help kids with the areas they're struggling with, many elementary math teachers, certainly not all, don't fully understand all of these new standards, and you need to understand this material well to teach it well. So those are some of the huge barriers facing the Tier 1 implementation. Now, we have some things in terms of how, in general, guidelines for how to develop the insights and understandings of the Common Core asked for. As I mentioned, asking kids to explain their reasoning. This is what I think is a terrible idea, to ask kids to write out their reasoning about every problem. It becomes odious. It's occasionally. Occasionally, they can write it, they can draw a picture, they can talk to you about it. It needs to be a mix of all these things, but they need to be occasions where students do that. Does it have to be the whole lesson? No. The other thing is, and this got lost in the early days of the math war, kids, in order to understand math, they need to be proficient with computation, with factoring, or knowing multiples, with solving equations. If they are not proficient in computation, they will not understand the concepts. Okay? That's been an insight in cognitive psych over this in the beginning of this century. And it sort of began with this article I show under point 3, Riddle Johnson, Bob Siegler, and Ali Bali, that showed that it actually is a reciprocal relationship between computation fluency and understanding. And more recently, Ken Kadinger and his colleagues at Carnegie Mellon and some of his grad students have looked at pre-algebra and algebra and found the same thing, that the ideas and literally solving equations and factoring, you need to be proficient in both, and if you do one without the other, it doesn't work. They're holes. So basically, good Tier 1 instruction, and this would be over, let's say, a week or a unit, includes all those components. And by procedures, I mean algorithms or solving equations or finding the area of a square or a triangle. There's a reciprocal relationship between them. They're all valued. The work on operations always needs linkage, anchors to the principles, especially the commutative property, the associative property, etc. And the same is true when we get to fractions. It's harder because the rules are more complex. Fractions are much more abstract than whole numbers. But especially when you go to things like, halves and thirds, kids are used to from sharing with a sister or whatever, but when you get to 87ths and stuff like that, it's phenomenally abstract for kids. One thing that Ken Kadinger and his folks fooled around with was was alternating days, that literally they had one day where they would talk about the idea, the mathematical idea, and the next day when they would solve equations. So the first day they were linked together, second day they're really solving equations. And also they were analyzing work samples. So they're looking at samples of what other kids have done and then telling if they were right or wrong, and if so, saying whether they were, if they were wrong, saying why. And then they'd go back to more work on the ideas. And that system seemed to work very well. And I have again lost my connection, but I'll just go off the slides here. So what we want to do is let me try to log in and see if I'm okay. I think I'll just be back and I'll be less discombobulated here.
If you need me to advance PowerPoint slides, let me know.
Why don't you do that, Molly? Why don't we go to the poll item for a second? I'll get my tech person in, okay?
Okay, so sure.
Yeah, okay. Okay, I'll be with you guys in a second so I can see the poll. I think, okay, we're set in a second. Okay. This one, I'm glad we got 100%. One second. Okay. But the main reason I wanted you to do it is, first of all, it's hard to just sit and listen to someone talk, but also to realize that this work isn't stuff so easy you can do in your sleep. It's not very hard for us, but it requires a bit of thinking and manipulating. And the other interesting thing is, as the next slide shows, is on the Innate. Now, this was quite recent. This was 2007, so there'd been a lot of math reform going on for quite a while. Half the kids in the grade 8 flunked that item. 49% passed. So something is still happening. The kids learn this in 4th and 5th grade, and by 8th grade, it's gone, which is rather horrible. And I now just want to show you a Common Core item. I think many of you probably have been oriented perhaps once too often to these, but as you notice, it starts off by the word understand, so understanding is clearly an objective that's going to be measured, and it talks right away about using a visual fraction model. So almost everything in the Common Core has this this feature. what I'm wondering at this point, if it might be, I don't know, well, I'm thinking we'll keep going and have the questions at the end. I was thinking of doing questions, but I need to speed up a little bit. We could always continue this if a key thing to look for in good Tier 1 instruction, and if it's not there, to supplement in Tier 2, is using Sibylla Beckman and what is often called in Asia strip diagrams, which are skinny rectangles. And you see the strip diagrams on the right, and they are not used that much in the U.S. We use a zillion representations, where in many Asian countries, Japan, for example, they use typically 3 or 4 representations. So there's definitely the pizza pie, the circle. There's usually a square, a rectangle, but this one is used all the time, and kids get real used to using it. It's sometimes done with fraction tiles, but the advantage of using this, and this is really what we should be seeing, and especially when fractions are taught in the intermediate grades, and even they should be used in middle school, is strip diagrams. Some kids may need it as tiles too, especially the younger kids, because the advantage of going from these strip diagrams to number lines is huge, and that would be, to me, something to look for in Tier 1 instruction, solid core instruction. This is a typical incorrect response to this problem, and it happens extremely frequently. Nancy Jordan is doing a current research project with at-risk and average ability kids in grades 3, 4, and 5. It remains a huge problem. Kids just add the tops and add the bottoms. And if they had to first do it with a strip diagram, and this is just an example of that, if they had to do it with a strip diagram, they would prevent just getting it over with quick. They would, by doing a lot of these, you get to see when, and there's a logic to when you can add the numerators together and when you can't, because this would be a case when a half and a third, you can't. They look different. And look what happens when you, in the middle step, when you break them into 6, they look different. So you need the picture in order to do computations properly, and that is why I would argue that something like this should be in Tier 1 instruction, period. Other thing that's great to add to Tier 1 instruction is, sometimes it's called CRA concrete, which is the oranges and pencils and cupcakes. Cupcakes would probably be used once a month, once a semester or something. But concrete, the visual representations, and there you see the common models of fractions, the area model, the sort of domino type model, and the number line. Yeah, I see someone said every day is a good day for cupcakes, and I agree, but I think with the obesity epidemic in the country, the oranges or carrots may be a lot better. But one thing that happens in middle school and high school is people never use concrete objects. Sometimes they're overused in elementary and not linked to math, which is something we want to always make sure is happening. But when we get to middle school and high school, sometimes kids need to see the concrete objects before they understand these visual representations like the 3 on the right. And that would be another feature of core instruction. Now, I know I didn't give you the most organized thing. Partly, I don't think this information is organized, and we're in a state of change. But I think this recap here is core instruction. Kids need to demonstrate understanding. They need to be using visual models. And at times, not every time, they have to be able to solve a problem in more than one way. So these kind of things need to be going on in classroom instruction, core instruction. And if they are, kids are going to develop insights into ideas. At least that's what we believe in theory, and these are foundational to algebra in particular, but also geometry and measurement. So how to do it: use a lot of visual representation, strip diagrams. Remember manipulatives, even if the kids are 13 years old, once in a blue moon, to make sure they understand what these pictures are, because sometimes they don't. I like the idea, there's no hard data yet on it, of either the alternate days or linking and integrating them, of integrating the ideas and concepts and procedures and integrating the word problems. And the next one is frequent, which is going to lead us right to our video in a second, Molly, is frequent teacher think-alouds. And often that involves explicit instruction. And sometimes it could also be in response to a problem the teacher is seeing. And the last one I've talked to death, I think. But what I want to focus now is teacher think-alouds. And to give you all a sense, and this is a tape that takes a little over 6 minutes, I am going to tell you a little about it. We'll do the poll right after. So it's a video example of explicit instruction. The one thing is, as you see this tape, watch for how what she doesn't do is model the procedure. She doesn't just model the procedure. She models it, but she thinks aloud, and she links this to visual representations and concrete representations. And one thing you'll notice, there's no discussion. She's not calling on kids. The reason is this is a demonstration tape that this math coach used, so it's a simulation. Normally, kids would have been involved, but you do get the flow for the think aloud. Like and this will be about 6.5 minutes, and Molly, it's fine to start it, and then we'll go back to the poll.
Instead of being set up horizontal or side to side, sometimes I see someone set the problem up in a vertical way like this. And I'm wondering, why would someone choose to make the problem vertical instead of horizontal and do partial sums like we've been doing? One thing I noticed is that in this problem, the numbers are in columns. So I noticed that the ones are in the same column, and the tens are in the same column, and the hundreds are in the same column. And when I see ones together and tens together and hundreds together, it makes me think about place value in our place value blocks. So I know that if I was to show this problem using place value blocks, it would look like this. I have 7 ones, 4 tens, and 3 hundreds. And I'd have 6 ones, 8 tens, and 2 hundreds. So if I was going to group my base 10 blocks together, I know that when I add 7 ones and 6 ones together, that will give me 13 ones. And I could record that. Same thing would be over here. This is just using numbers instead of my pictures. And if I was to add my 10 blocks together, I would have 8 tens and 4 more tens, which would be 12 tens. And so over here, 8 tens and 4 tens is the same as 12 tens. And if I were to add my hundreds together, I would have 5 hundreds blocks. And that would be 5 hundreds over here. But I'm looking at that number, and I've never seen a number recorded like that before. 5, 12, 13. So I'm thinking there must be something else that we need to do. When I look at my base 10 blocks, I know that when I see 10 single blocks or 10 one blocks, that I can make those a group. And once I put my 10 one blocks together, that's the same as a 10. And that 110 can be recorded over here in my tens column. So now, instead of having 13 ones, I have 3 ones, and now I have 5, 10, 13 groups of 10. But when I look at my tens column, I see I have 13 groups of 10, and I know that if I put 10 groups of 10 or 10 tens together, that's the same as 100. So I can put that 100 over here. So now instead of having 13 tens, I'm left with 3 tens, and instead of having 600 or 500s, I'm now left with 600s. So altogether, I have 600s, 3 tens, and 3 ones, and that's the same as 633, which gives me the same answer that we got with our partial sums of 633. So we know this was a good strategy because we got the same answer here that we got with our partial sums of 633. But that seemed like there was a lot of crossing out and changing to do. And I'm sure there must be a more efficient and faster way to solve this problem without having to do all that crossing out. So if we look at our problem again and we start with the ones, I know that 7 ones plus 6 ones is 13 ones. And I know that 13 ones is the same as 110 and 3 ones. So I'm going to record my 3 ones in the ones column, and I'm going to put my 10 with the other 10s. And now I'm going to see how many 10s I have. I have 8 10s and 4 10s and 1 10. And 8 10s and 4 10s and 1 10 would make 13 10s. And I know that 13 10s is the same as 100, because when I put 10 10s together, that makes 100, and then I have 3 10s. So now I'm going to record my 10s, and I have 3 10s, and I'm going to put my 100 over here with the other hundreds because we want to keep those together. Now I have 100, 300s, and 200s, which would be the same as 600s, and I get the same answer of 633.
Okay. I think we got some interesting exchanges. We have 11 minutes left. Why don't you just spend a minute on this poll item, and what I'm going to do is go through some of the questions. I've already done some of that, but this will just be, I think, kind of interesting to all of us. And we can also continue with the Q&As next week.
I think that's about it for the
Yeah,
response.
okay, thanks. So just looking here at, not surprisingly, the major issue by far is kids getting opportunities to explain and show their understanding. And what seems good, at least, is this is helping to indicate an area that, I mean, this is obviously a sample from throughout the state of New York, but not necessarily, demographically perfectly representative. This is a huge area, and I would expect that would be the hardest area. Teacher think alouds is a problem for some teachers, but this area, it takes a lot of skill to do, and it can be kind of a cop-out in a way, just asking kids to write it out. So I think this gives a good picture, and the integration of word problems is still not a prevalent factor, and explicit instruction that helps, that creates the links, which is number 7 in your poll, I think is a great one to to set up a situation where kids can be given opportunities to explain, because if the teacher models this, kids start to at least hear receptively the language of doing this, and then if you give them opportunities, they can do it their own way. I have time for just a few of the questions. I, not surprisingly, prepared a little bit too much, but I'll start with just a couple of comments. There's one from Elizabeth saying, many of the students she's assessing for triennial reviews get the fractions incorrect on the Y at 3, and yeah, that is an area that is often covered in interventions, covered in special ed, but it needs to be covered in so much more depth, and it needs to be covered the right way. Let me look at a couple of others that aren't logistical. So we also get that one of the triennial goals for eighth graders is knowledge of fractions, and someone else was talking about 12th graders who he has to teach fractions concepts to. And when we did a survey of algebra teachers with the National Math Panel and asked them what were the major problems kids had, they said, number 1, they don't understand fractions. Because if you don't understand fractions, Algebra 1, you're lost with 3z equals 11, without understanding the ideas. And it just seems that kids at some point in time need to be taught it in sufficient depth with sufficient time coverage so that they learn it. Tom Mariano said he found a neat website with CRA approaches to key standards. That's a concrete representation abstract, and that's something maybe, Molly, we could share with the group, and at the next session or somewhere like that. We have a question about addressing the way to bridge invented strategies to more conventional. A typical way is the way that I've seen Deborah Ball and some of the University of Michigan people do it is several kids present invented strategies, and then you can begin to discuss which is more efficient. I'm sure there are other ways, but that may be the best I could think of at this particular minute. In terms of Tom Mariana had some concerns with that illustration, and basically that putting representations in the column was kind of weird, because in the hundreds column or tens column, you should really have one number that represents the number of tens, and here there are all these boxes and little things there, and I think, I agree it's an imperfect representation, but was a way to get it across, and it probably wasn't ideal. But the main reason I showed it was it was an example of explaining why, in the procedure, explaining why things are done, and so that, we can argue, and I think you're also going to run into imperfect visual representations and strategies that, some may disagree with, but when things are more on this track, we think it's going to get at the main goals. And someone, Hannah, said, isn't the whole point of the Common Core, I assume the Common Core standards to teach understanding of why instead of memorization? And so that was basically what the purpose of this lesson was, and in that sense, it's just an example of that. And I think think-alouds, too, are far too infrequent, and they're infrequent in two ways. Some teachers hardly do them. Some only model the algorithm, but the other is one is not enough. One is not enough. I think now Molly has something up for you because it's 2:13. Thanks for attending. Please take a few minutes to complete this brief evaluation. You can email in to her any other questions you have, and we could handle them next week, where we're going to talk about an RtI framework and screening. And thank you very much from my end.